Hello everyone, this is Mr. B with some Algebra 2 notes, 3.2, solving systems of equations algebraically. It's going to be very different than when we're solving them through graphing, of course. We're going to look at this in a pretty different way, but it'll give us a very specific answer when graphing would not be able to do so. I'll give you guys an example. This system of equations is the first one we'll solve. If we look at it on a graph, pull over Desmos here, looks something like this. It's intersecting somewhere between, I mean, it's hard to say. Even when we hover over it, this is not giving us an exact answer by any means. So, pull up drawboard again. Here we go. We'll attack this algebraically and get to a exact solution to see exactly where these two systems of equations equal each other. All right, so first off, just to fill in this blank here, solve one of the equations for one variable, and then substitute that into the other equation. That's all we have to do here. The easiest one that I would solve for here would be x on this left-hand equation. We can do that just by one step, just subtract 4y from each side. So we'll do that now. Let's see, we'll get x equals 5 minus 4y. All right, easy enough. Now we take this x and these x's here, and we just sub them out. That's all we do. It's nothing too crazy, nothing too fancy. So we'll just jump ahead and do that. So on this side, the left hand of this equation does not change at all. It's 2y minus 5 equals 3. And then in parentheses, we'll put in this 5 minus 4y minus 5. First step for this would be to distribute the 3 into both of these terms. This left-hand side, again, does not change. 2y minus 5 equals, this would give us 15 minus 12y minus 5. All right, I would add 12y to each side. That would give us 14y. And I'm also, let's see, that's all I'll do for right now. I'll combine like terms on this side. 15 minus 5 would give us, let's see, 10. I'll add 5 to each side. So that gives us 14y equals 15. And then I would divide each side by 14. That would give us y equals 15 over 14. All right, perfect. That sounds good. Now, to solve for the x, we need to take this number and do one final step. We just need to plug it into this equation. That's what I would do. We've already done some arithmetic up here to get the x by itself. Why not capitalize on that and not do the same step twice? We would have to anyway. So I'll plug it in here. I would get x equals 5 minus 4 times 15 over 14. So remember, when we're multiplying these fractions, it's going to be, really we can think of this as a 4 over 1, and this 15 over 14 is just 15 over 14. We're going to multiply the whole thing together. Bottom gets multiplied across, and then top gets multiplied across as well. So the bottom's not going to change, but the top is definitely going to change. We'll have x equals 5 minus 60 over, let's see, 14. All right. Now we need to convert this 5 into something that we can actually do something with over here. Well, the first thing I'm going to do is actually reduce this. Both of these share a common factor, so really this is x equals 5 minus 30 over 7. That's just going to make our math easier, I think, in the long run. Now I'll multiply 5 by 7 over 7, which is just 1, so we're not changing the number at all. So we get x equals, let's see, that's 35 over 7 minus 30 over 7. And that gives us x equals 5 over 7. And now we can plug these back in. I always recommend doing that. I'll use this equation over here because most of our arithmetic has been around this. The first time through recording these notes, I actually messed up twice in a row. I got the wrong answer. Just had to take a step back and kind of recalibrate. So let's do that now. I'll plug in 2 times 15 over 14 minus 5 equals 3 times 5 over 7. What am I writing it up there for? 5 over 7 minus 5. I actually see these 5s turning up on both sides, so I'm just going to add 5 to each side. That's totally valid. So really I get 2 times 15 over 14 equals 3 times 5 over 7. All right, so multiplying this one on the left-hand side here would give us 30 over 14, and this would give us 15 over 7. They're actually the same number. This one's just not reduced quite yet, so we'll do that. 15 over 14, 30 over 14 would reduce to 15 over 7, and that proves that our two solutions work. Now, the correct way to write this down would actually be as an ordered pair. That's what we're going to look for, and I'll prompt that on the test when the chapter comes up, so don't stress about it too much. I'll ask for it in an ordered pair and give you a blank for it. So we would write this just like we would a point on a graph, because really that's what we're describing, where those two lines intersect. We would get x equals 5 over 7, comma, and then y, that's 15 over 14. And that is really what we're looking for. We're not looking for that. We're not looking for that. Those are steps to get to this final solution. And you don't need to check either. I did just to, I guess, mainly make sure that my arithmetic was right this third time through the same problem. But yeah, we are going to look for it in that ordered pair, though. All right, here's another question here. Word problem, though. So let's see. Furniture store has lost their individual sales receipts, and their inventory was not correctly counted at the start of the month. They do know they've sold 48 total chairs, and the total amount of sales is 13,930. Rocking chairs sell for 265, and the exterior sway set sells for 320. Develop two equations and use a system of equations to determine how many of each type of chairs were sold. All right, I am going to highlight what I know that I need. So let's see. We know they've sold 48 total chairs. That's going to be important. The total amount of sales is 13,930. Rocking chairs sell for 265. Exterior sway sets sell for 320. This one we're not going to look for in ordered pair because neither of these is really assigned an X or a Y value. That wouldn't really make any sense. So let's see. We know they've sold 48 total chairs. I'll just use R for rocking chairs. And let's see, rocking chairs. And I'll use S for sway set. So we know a couple things. We know that they sold 48 total chairs. So we know that R plus S equals 48. We also know that rocking chairs sell for $265 a piece. So for every rocking chair sold, we're going to multiply that by 265. So 265R plus 320S. You know what? I'm actually going to use a different letter for this because they look like 5s here. I don't really want to use E either. I'm just going to use X. E is an actual natural number. It's kind of like pi in that there is some significance to it. So you don't really want to use that as a variable unless it's very clear and you've run out of options. So I'm just going to use X for the sway set. All right, so we know that each of these chairs sold for their respective amounts, and the total amount was 13,930. Now there is some fancy work we can do with this equation to divide everything by 5 because there is a common factor there. I wouldn't, just because when you're doing this type of an equation, it's very, very easy, especially with this equation, to solve for one of the variables. Then you just plug it in, let the numbers get big. It won't really matter. We're going to get to the right answer either way. So I wouldn't stress about that too much. So I'm going to solve for one of these numbers here. I'll solve for x. It does not matter which one we solve for. We'll get the correct result as long as our arithmetic is sound. Either way. I'm going to move this over, though. Let's see. Okay. There we go. So I'm going to subtract r from each side. So I'll get x equals 48 minus r. Then I'm going to take that value for x and just plug it into our other equation. So we'll get 265r plus 320 48 minus r equals 13,930. So I'm going to use my calculator for this distribution. 320 times 48 is going to be a pretty big number there, but that's okay. That'll make sense here in just a few moments. So 265 r plus 15,360. Let's see, minus 320 r equals still 13,930. When the numbers get really big like this, I always recommend just keep your work as organized as possible. Take this in small steps. So I am going to subtract 15,360 from each side. I'm going to use my calculator for this. You can do it longhand, but why would you? It's just going to be easier if we use a calculator for a lot of these steps. So 13,930 minus 15,360 gives us negative 1,430. And then we have our r's over here, 265 minus 320 would give us negative 55 r. And now we just need to divide. So we'll take that negative 1,430 and divide it by negative 55. We'll get r equals 26. So what does that actually mean? Well, it means that we've sold 26 rocking chairs. Now we can take this 26 and I would say plug it into this one. We can plug it in to the larger equation here, but it's just going to be way more steps. So I'll plug it in here. We've got 26 plus x equals 48. I'll subtract 26 from each side. And just for the sake of getting it right the first time through, I'm going to use my calculator. X equals 22. And remember, we don't want this as an ordered pair because x and r isn't going to make sense. If someone wrote an ordered pair for this question, I wouldn't know what it actually meant. So I would say we sold 26 rocking chairs and 22 sway sets. And that would be the answer for this one. I've got another method for you guys for solving these systems of equations that I think some of you will really like just because it's, I think, more elegant. I like how this method works, and it's honestly the more commonly used method because it is applied more, especially on this next section when we're dealing with multiple variables. It's going to cut down on your work. Your numbers won't necessarily get super huge because we're working with addition instead of multiplication. You'll see what I mean here in a sec. So the first thing first, fill in these blanks. Inverse method. Manipulate the equations such that one variable will be negated. This is just the technical term for basically removed from the sum of our equations. And that'll make sense as we're going through. So what we really want, if we remember what the inverse property actually means, it means that if we have some number a and we add the inverse of it, we'll get 0. So we're going to add both of these equations together across their equal sign. It'll make more sense as we're going through if this doesn't make sense already. So what I'm going to do to this left-hand equation, let's see, this one here, is I'm going to multiply everything by negative 2. So I'll get negative 4x minus 6y equals positive 4. The tricky thing with the inverse method is that your negatives can get lost, so I find it's very helpful for me, not to say it out loud necessarily, but just to go through every step methodically in my head. Now you'll see something kind of unique about the two x's that we have with our two equations now. Because remember, this top equation and this bottom equation are not exactly the same, but they are the same. They're talking about the same line. The same relationship between these two numbers exists because we multiplied the entire thing by a constant. Now the thing to note here is this negative 4x and this positive 4x, they're each the inverse of the other. So if we add these together, just like we saw over here on the right-hand side, we're going to get 0 because they're real numbers, and negative 4x and 4x are real numbers. So let's add these equations together. So I'm going to add negative 4x, negative 6y, nothing for there's no constant on that side, and then I'm going to add a 4. So I'll just bring that down. 4x plus negative 4x is going to be 0. 7y plus negative 6y is just going to give me y. There's nothing being added to this negative 3, so we have to carry that down as well. And 0 plus 4 is 4. So now our new equation, if we want to clean this up a little bit, is y minus 3 equals 4. We'll add 3 to each side, and we have y equals 7. Okay, now, just like we did above with the first example, we just need to plug this in. Either one is going to be fine. I'm going to pick the left-hand side equation just because it's a little bit simpler, and I'm going to use the pre-edited version before I multiplied everything by negative 2. There's no reason not to. You can kind of pick and choose. Each individual step, you need to follow the same order of steps, but the exact path you use to get to the correct destination for a lot of these questions is pretty much your own. You can go whichever way you'd like. So I'll plug in 7 for the y. So we have 2x plus 3 times 7 equals negative 2. Well, 2x plus 21 equals negative 2. I'll subtract 21 from each side, so I'll get 2x equals negative 23, and then divide each side by 2. We get x equals negative 23 over 2. And just like we did above, I'm going to check these because like I said, I already messed up a couple times tonight, so I'm just going to make sure I'm doing it the right way. Let's see, we have 2. I'm going to plug it into the left-hand side. Smaller numbers, why not? Well, you know what? I'm going to plug it into the other one because we just found x with that, so we know it's going to work for this equation. Let's try it with the other. So we have 4 times negative 23 over 2 plus 7 times 7 minus 3 equals 0. Let's see. Negative 23 times 4. I'm just going to use my calculator. Why not? Let's see. 23 times 4 is 92 over 2. Negative 92 over 2. Plus 7 times 7 is 49. Minus 3 equals 0. Well, 92 or negative 92 divided by 2 would be negative 46 plus 49 minus 3, I think does in fact equal 0. Yeah, because 49 minus 3 would be positive 49. Hey, look, the inverse would show back up again. We'd get negative 46 plus 46 does in fact equal 0, so this checks out. Now to write it as an ordered pair, remember, we would put this in parentheses, just like we're describing a point, because really, that's what we are. 23 over 2, 7. That is what we're looking for. Right. One more here. We're actually going to use the inverse method to prove that this system of equations has no solutions. which, if we remember, that just means they're going to be parallel lines. All right, let's jump through it. I am going to take this. Really, we can focus on the 2x or the y here, and you'll kind of see how this kind of symmetry works out. So to get from 2x to 8x, I'm going to multiply everything, or to get to the inverse of 8x, I'll get to negative 8x. So that's going to require a multiplication by negative 4. So we'll get negative 8x minus 4y equals 4. And now we add these together, remember. We're going to add a negative 8x, a negative 4y. We're going to add 4. All right, so we'll get 0 plus 0 equals 21. Well, this just told us that 0 equals 21. If we get to a spot in solving a system of equations like this, and we get something like this, where it says a one number equals something that it does not equal, then we know that these two lines that we're looking at are parallel. We could prove that if we wanted to, but the slope for both of these lines is going to be 2. The intercepts are different. We're looking at two parallel lines. Yeah, that's not going to work out. If we were to get something like 0 equals 0, I know we absolutely did not in this equation, but if we were to get something like this, we would know that not only are the lines parallel, they're the same line, and then you would have infinite solutions. That's not what we're looking at here. We're looking at 0 equals 21, means parallel lines, so no solution. If you guys do have extra questions on this, please see us in class. This is a pretty critical piece to understand as we're going further and further in Algebra 2. We're going to be doing manipulations with these types of equations a lot. So if this is confusing to us, we really need to buckle down and get the extra help we need. Miss Kavanaugh is, I know, going to be great at teaching this. This is, I think, a really, really fun topic, and I think that the way that she thinks and explains things is going to do you guys really, really well. So if you have questions, please bring them up, and we'll see you guys later.